Hello, my name is Ben and this is my industrial electronics final project. I'm going to quickly go through how I solved each problem, the main result I got, and then explain how my Arduino circuit works and why I made certain design choices. Question 1. For the first question, I'll focus on explaining the basics in my own words. Electricity is basically the movement of electronic charge, usually electrons. When those electrons move through a circuit, they carry electrical energy that powers devices. Voltage is what pushes the electron current through the flow of the electrons, and resistance is what slows them down. Ohm's law just connects all three ideals together. I also explained AC current, which switches directions back and forth, compared to DC, which only flows one way. I went over things like peak value, frequency, and period, since those are key for AC circuits. And then I talked about diodes and transitioners. Diodes only lets current flow one way, and transitioners can act like a switch or amplifiers. I finished this part by explaining basic logic gates like AND, OR, NOT, and used in digital systems. Question 2, I analyzed the series parallel DC circuit step by step. First, I assigned values to the voltage source and resistors, and then I simplified the circuit by combining the parallel resistors first and then adding the series ones until I got one equivalent resistance. Once I had the total resistance, I calculated the total current from the source. After that, I worked backwards to find the voltage and current across each resistor. The main result was getting a consistent set of values that followed Ohm's law and matched how series and parallel circuits are supposed to behave. I summarized everything in a result table to keep it organized. For question 3, I used Kirchhoff's law to analyze an AC circuit. I started by assuming current direction so the mass stayed consistent, and I used Kirchhoff's law, current law at the nodes of Kirchhoff's voltage law around the loops. After writing the equations, I solved them using substitution to find the unknown currents. The key results was finding all the loop current and showing the Kepler's laws correctly describe what's happening in the circuit. For question 4, I analyzed a parallel RLC AC circuit. First, I picked the voltage and frequency values, and I calculated the inductive and capacitive resistance. Since it's a parallel circuit, I worked with admittance to find the total. Once I had that, I calculated the total current from the source and then the individual currents through the resistor, inductor, and capacitor. The main result here was seeing how the currents behave differently in each branch, especially how the inductor and capacitor are out of phase with the voltage. And for the last question, I explained how Arduino circuits with one LED and 2 buttons work. The goal is to connect one LED using 2 push buttons. Each button can turn the LED on or off. I used the Arduino Uno and LED with the resistor, 2 push buttons, and a breadboard. The buttons are connected to input pins and the LED is connected to the output pins. In the code, I read the button states and toggled the LED when the button is pressed. I used internal pull resistors to simplify the wiring and added a debalancing so one button press only counts as one. That was an important design choice to make the circuit reliable. My conclusion: overall, this project helped connect the theory we learned in class to real circuits and real code. It reinforced how to analyze circuits step by step and why those methods matter in real application.